Hello, we have this tricky integral in our part, not so tricky once you go through it, but for now, let us see how we can solve it. Okay, so what you see is there is this term x plus 1, right? X plus 1, once it has this 1 by 3 to the power 1 by 3, once it has 1 by 2. Now, in order to deal with this, what we can say is that we can take a term which basically like which is divisible by both 3 and 2, right? Now, what I mean by that is let us substitute x plus 1 to the power 1 by 6. Okay, 1 by 6 it equals to t. Okay, now we'll do that. Now, if we take this, then what comes out to be x plus 1? Then x plus 1 to the power 1 by 3, this is t square, right? This is t square, and x plus 1 divided by sorry, to the power 1 by 2, that equals to tq, right? Now we have this. Now from this, what we can say is this, that x plus 1, sorry, I have a little bit of uh, okay, I think that like thickness is enough. So there, x plus 1 divided for equals to t to the power 6. Basically from this we can write that. Okay, now why we are writing this? Because we have to transform dx. So dx is basically 6 t to the power 5 dt, right? Now what we can write from all of this term is that this particular term is equals to, first of all, what is this? T square. This is tq. Okay, and in place of dx we can write 6 t to the power 5 dt. Okay, now we have this particular form. Okay, now many of the terms can be easily cancelled out. So from here we can say that t square we are taking as common. This is 1 plus t. All right, this is 1 plus t, and what is this? This is t to the power 5. So here it gets cancelled and it becomes 3. Dt is of course there. So finally we reduced our term to this 6tq by 1 plus t, right? 1 plus t, right? Now of course dt is there, right? We can't forget the dt. So we have reduced our term to this one. How can we proceed from here? So that is the question, right? Now let us go through this. So again, what is our term now? That is 6tq by t plus 1. Okay, dt. We have to do this. Now of course t has, now we can't forget this, that's x plus 1. Let me write this in another color actually, because this is not the part of the problem, this is just our assumption. So it will be t equals to what? T to the power 6 equals to x plus 1, right? So t to the power 6 equals to x plus 1. This is the our substitution that we had taken. Okay, now let us go back to the problem. In order to do that, we can't have this kind of term in the denominator, right? So we'll have to change that as well. So we'll substitute again, t plus 1 equals to z. Okay, that will substitute. So here we have z or z depending on where you are. Now we can take the 6 out as well. Now we have transformed tq. So tq is basically z minus 1. Z minus 1 is t, so z minus 1 q, right? And of course from here we can write dt equals to dz or dz. Okay, now we have this dz here. Now what is going to happen is we have to expand this. So first of all, this is zq minus 3z square plus 3z minus 1, right? And we have z here, and we have this like this. Okay, now that we have this, we can finally write it in better terms, which is going to be z square minus 3z plus 3z minus 1 by z. Okay, now dz. Okay, if you write this better, how it comes out to be is, so okay, what is it now? So it is again 6z square minus 3z plus 3 minus 1 by z, right? All of these terms. So if you do that, this is simple, right? So it is 6zq by 3. This is 3, friends. Okay, this is 3. We can't not write it better. Okay, so this is 3 by 3z square by 3. Okay, this is 3z 3z. Okay, I forgot the 6 again. Okay, but 6 I will write it like this. Okay, so this is 3z by 3. This is 3z, this is 3z, right? So yeah, this is 3z, and this is going to be ln of z, right? Z or z again, depending on where you are. Plus c, this is a constant term we have to introduce here, right? Now that we have till here, we have to substitute it back. What was it? What was it? Substitute. So t to the power 6 equals to x plus 1, and we have t equals to z minus 1, right? So again, we'll write it this way: t to the power 6 is equals to z plus 1, sorry, x plus 1, right? Again, this is this, okay, x plus 1, and z, what was z? Z equals to t plus 1, right? So we can write this as z equals to t plus 1, right? Okay, so z equals to t plus 1. So we have that. Now we'll transform z to x, right? From this we can write that z equals to x plus 1 to the power 1 by 6 plus 1, isn't it? All right, now that we can write it, so first of all, what happens? First of all, this particular term, so this 6 and 3, these will become it, make it 2, and we'll write the z term. Z term is basically x plus 1 to the power 1 by 6 plus 1, right? And this whole thing will be q. Okay, now we'll have this minus term, minus this 6, this 3 and 3 cancels out, right? So we'll have this 6 directly. Okay, now this 6 directly, now it is z square. Again, we'll write this particular term in z. So this is x plus 1 to the power 1 by 6 plus 1, and this is square. This is the square we are channeling, right? Now this is there. Now this plus 3z term will write, so plus 3z is plus 3 and z, simply z. So x plus 1, sorry, we'll write this again in black. Okay, so this thing is x plus 1 to the power 1 by 6 plus 1. Okay, now you have this, and minus ln of simply z, so that would be x plus 1 to the power 1 by 6 plus 1. Okay, now you have that with you, plus c, of course. Okay, so you can further expand this, but idea of how to solve this particular problem in integration is this. Okay, hope you like this. See you in another video with another problem. Bye for now.